Hey guys, so I thought I'd make another video going over some of the information that's up on Google Classroom. And this is all about circles and circumference. This is a study guide intervention worksheet that is on there. And I really like these because the top gives you the information you need to remember in order to do the exercises. And this is basically what was in the note video that is posted earlier. But it's just another way of seeing the same information. So I actually really like these a lot. And they typically give an example as well. Okay, so this is actually telling you how to do the tasks ahead. So I'm going to go over the answers here. So hopefully you've tried this. I hope, the idea is that you've tried this already and you want to check your work. Or if you're stuck, you can, go to the problem that you had stuck on and you can see what I did and then hopefully do as much of it on your own as possible. Okay. Anyway, let's go ahead and get started. So we're starting here with the circle and all these problems on the left, there's only 7 exercises. Let me zoom in here so you can see a little better. All these exercises on the left are referring to this circle here on the right. Okay, so this circle is right here. Let me go ahead and use blue. So name the circle. We know we name a circle by its center point, which here is R. So we're going to call this circle R. Okay. Name the radii of a circle. Well, there's different radii here. There's a whole bunch of line segments that start at the center and go to the edge. So we're going to call it RB, RY, RA, RX. And again, remember, you could reverse the order of those letters and it's totally fine. Name the chords of the circle. So these chords are here and here. The endpoints are on the circle itself. So AX and YB. Name the diameters of the circle. So diameter is a line segment or a chord that goes, I guess technically these are chords as well. I shouldn't forget those. So AB and XY. Those are also chords. This is just special chords. So these special chords happen to be the diameters as well. So XY and AB. And you'll remember they are the diameter because they're a chord that goes through the center. All right, if AB is 18 millimeters, find AR. So AB is the diameter. So we're going to say diameter equals double the radius, right? So we're told we have the diameter is AB. So we're going to say 18, and AR is the radius, you can tell, because it's half of it, right? So 18 equals 2R. So we're going to divide both sides by 2. So I'm going laterally here. Normally I like to solve these vertically. And R would be 9 millimeters. Okay. If RY is 10, so RY is the radius here. RY is 10, find AR. Well, all radii are congruent, so we know AR would be 10 inches. The radii of the same circle, obviously, 10 inches. And AB is going to be the diameter, which is double that, so double that would be 20. So AB would be 20 inches. Okay? Is AB congruent to XY? So AB is the diameter. XY is the diameter. Yes. Oh, let me go in here. Yes, they are congruent. You may be asking yourself, why? Why are they congruent? Well, diameters of the same circle will be congruent. Because, and same with radii as well. Diameters and radii, it's just fun to say radii, of the same circle are congruent. I don't know if you can see that. There you go. Are congruent. Okay. All right, so hopefully that helps. Let's go ahead and flip it over. All right, this is more about circumference, right? And remember the circumference formula is 2 times pi times r is the circumference. In other words, double the radius or the diameter times pi. Okay, find the diameter and radius of a circle with a given circumference. Round to the nearest hundredth. We'll do the odds. We're not going to do all of these. So C equals 40 inches, and we're looking for the diameter and the radius. So we're going to say C equals 2 pi r. So we're going to say, so 40 is the C. 40 equals 2 pi r. Interesting. So the radius is going to be 40 divided by 2 divided by pi. So we're going to say 2 pi. These cancel out. I'm just going to do this here. So we're not going to be able to do all these because of spacing, unfortunately. That is one of the problems of these sheets. A lot of these you have to do work on a separate page, which I'll do actually. Let's build another piece beside here. So R is equal to this, so this cancels, so 40 over 2 is 20, so 20 over pi. That'd be the radius of this. And double that, right? So double that, so that's the radius, is going to be just 40 pi. or 40 over pi rather, because double, yeah, so 40. So, and the diameter would be 40 over pi, and that's inches. I'll do the next order here. So, oh, they just made this mean on purpose. Look at this. So number 3, we have c equals 15 and 62 hundredths meters. So this is just some simple algebra, honestly. That's all this is. So 15 62 hundredths equals 2 pi r. We'll solve for r. So we're going to divide these both by 2 pi. All right, we're going to cancel that out. Let's go ahead and let's be lazy and use our calculator for this part. So we're going to say 15 and 62 hundredths divided by 2. And that's 7 and 81 hundredths. So 7 and 81 hundredths over pi. And that would be the radius. And that's going to be in, what is it, meters? Yeah. Meters. And double that is just going to be 15 and 62 over equals diameter. Meters up here. So that'd be number 3. And the last one, number 5. So we have, this is just kind of like algebraically solving it. That's all this is. 79 and 5/10 yards. So we'll write the formula. So c equals 2 pi r. And our c is going to be 79 and 5/10 equals 2 pi r. We're going to go ahead and solve for r. So we're going to divide both sides by 2 pi. And let's go ahead and, again, we're going to be a little lazy here. 79.5, oh, what am I doing? 79 and 5/10 divided by 2. So we have 39 and 75 hundredths over pi, and that's yards, and that is our radius. Just double that, so it's going to be 79 and 5/10 over pi yards. That's our diameter. Okay, so that's how you do the odds there. All right, let's look at these other ones. We'll do the odds down here. Find the exact circumference of each circle using the given inscribed or circumscribed polygons. This is interesting. This is a little different. So, okay, just to clarify, because we may not know what the difference is between these two words, this means it's something drawn inside of something else. That's inscribed, inside. Circumscribed means it's something drawn outside of something else. So for example, this would be inscribed, this triangle is inscribed to the circle. You know, this rectangle, or look, we don't know if it's a rectangle, but it looks like it. It's a quadrilateral is inscribed inside the circle, whereas here we have what appears to be a quadrilateral circumscribed around the circle. So that's the difference. So actually, of all these, only one of them is, let me see, zoom down here, only one of these is actually circumscribed. The other 5 are actually inscribed. All right, let's try the evens. So it's asking us to find the circumference, all right, the exact circumference. When they say exact, that means we're going to leave pi as pi. We're going to leave it almost as, it's almost like a variable, really. So yeah, so we're looking for the circumference. So remember, circumference equals 2 pi r. Okay, so we know this side is congruent to that side. So this is actually an isosceles right triangle. An isosceles right triangle means it's a 45, 45, 90. Okay, so what we need is either the radius or the diameter. We need to find this value here. Okay, and we can do that. We could do that we could actually use Pythagorean theorem, or we could just use a special right triangle formula. All right, so we know if this is x, this is x, this is x radical 2. So we know the diameter is actually x radical 2. So the diameter is, and that would be 9 radical 2. So 9 radical 2. Or if you wanted to, you could use the Pythagorean theorem and say 9 squared plus 9 squared equals x squared, and find x being the hypotenuse, obviously. So this is 9 radical 2. That's our diameter. Half of that would be, 4.5 radius equals 4.5 radical 2. And we can plug that in. So here's the thing. 2 times r is actually the diameter. So you can go ahead and just put that next to pi. 9 radical 2 pi, and that would be the circumference, inches. If you want to, you can go ahead and put 4.5 radical 2 in for r and multiply by 2 and get that, but just save yourself the trouble. Okay, let's try this one. That's an interesting problem. Here we have what appears to be a looks like a square. They don't tell us these are congruent. That's interesting. We know it's a circle though, so this is a square. And we know that this is going straight through it. It looks like it. Now the problem, here's actually the thing here with this problem. There's actually not enough notation to make this clear what they're trying to tell us. So unfortunately, it's not a great example, but I'll go ahead and cheat a little bit here. We're going to say these are, I'll put some actual marking here. And we know, and they don't tell us that's the center. We have to assume that's the center for that to work. So anyway, this would be 11 as well. Why did I put a pi there? 11. So remember, 2 pi is equal to d. So we're going to go ahead and put that in front of the pi. So it would actually just be 11 pi yards. And that is going to be the circumference of that circle. This last one down here, again, this is an isosceles right triangle. It's actually at 45, 45, 90. You can tell because these legs are the same. So this would be, this is x, this is x, this is x radical 2. So x radical 2 would be radical 2 times radical 2, which is 2. So the diameter is 2. And the diameter is 2 times r, so it's just going to be 2 pi. And that's going to be centimeters. Okay. So yeah, these are interesting. These are pretty tricky, to be honest. So try those out. Hopefully those are helpful. And actually, I'm not. If you want me to go over these later, I can. Just let me know. I'm more than happy to show you those. So hopefully that was helpful, guys. Let me know. Thanks. Bye.